Okay, so let's see if you got the same thing that I did. Iron 3 oxide, 2 monoatomic ions, plus 3 minus 2. Is that what everybody got? Sulfuric acid, hydrogen's a plus 1, oxygen's a negative 2. So I get plus 2, negative 8 is equal to 0. So sulfur is a positive 6 total, divided by 1 is a plus 6. Yes? Chloric acid, hydrogen plus 1, oxygen minus 2, negative 6 plus 1 adds up to 0. We need a positive 5. Divided by 1 gives me a plus 5 for chlorine. C6H6. I don't know any rules about carbon, but I know that hydrogen is a plus 1. 6 times a plus 1 is a plus 6. Has to add up to 0, so I need a negative 6 divided by 6 gives me a negative 1. Now, did anybody have that one switched around backwards? Okay, because you glanced at that and thought, oh, hydrogen's written second, it must be a hydride. But that's in metal hydrides. Is carbon a metal? No, carbon is to the right of the stair-step line. It's a non-metal. So we follow the hydrogen rule, and then carbon has to be a negative 1 by comparison. Now, this next one is probably the most tricky one because we start with the rule that says everything adds up to 0. Now, the next rule is fluorine is a negative 1 always. So fluorine gets a negative 1. Hydrogen is a plus 1 unless it's a metal hydride, which this is not. So I have 1 hydrogen at a positive 1, 1 fluorine at a negative 1, and I haven't dealt with oxygen yet. But a positive 1 and a minus 1 is already equal to 0. So what does oxygen contribute? 0 divided by 3 is 0. So in this case, oxygen is 0. It's not a peroxide, and it's not oxygen at a negative 2, but because it's hanging out with fluorine, and the fluorine rule hierarchy trumps the oxygen, oxygen is 0. Because fluorine is the most electronegative element, so it can hog all the electrons. So we can recognize redox reactions because we see a change in oxidation number. We can also recognize redox reactions because we recognize oxidizing or reducing agents, or because we recognize the type of chemistry that's going on. Combustion is redox. Single replacement is redox. So there may be times you can recognize it by the type of chemistry. You can also recognize what isn't redox. Double replacement chemistry rearranges pieces, changes partners at the dance. Double replacement is not redox. So you can recognize that that is not redox. So let's look at some examples. Remember, we're defining oxidation as an increase in oxidation number. Reduction is a decrease in oxidation number. So let's look at these reactions and find out what's oxidized, what's reduced. Well, this one is an ionic equation. I have an iron 2 plus ion. It's a monoatomic ion, so its oxidation number is plus 2. In the permanganate ion, I start with my minus 2 rule for oxygen. 4 times a negative 2 is a negative 8. This has to add up to negative 1, the charge on the species. So I need a positive 7 divided by 1. Manganese has an oxidation number of a plus 7. The hydrogen ion is a monoatomic ion, plus 1. Ferric ion, plus 3, monoatomic ion, oxidation number is plus 3. The manganese ion has a real charge of plus 2, so it appears to have a charge of plus 2. The oxidation number is the same as the charge. For water, hydrogen's a plus 1, oxygen's a minus 2. 2 times a plus 1 is plus 2, minus 2 is 0, so it checks out. So now when I look at this to see what changed, iron went from a plus 2 to a plus 3. So that shows an increase in oxidation number, so it is oxidized, which makes it the reducing agent. Now, what else changed in that chemistry? What else changed here? The manganese. Manganese went from a +7 down to a +2. So that was a decrease in oxidation number, which means the manganese was reduced, so it is the oxidizing agent. All right, let's look at the next one. Hydrogen gas plus copper 2 oxide solid makes copper solid plus water gas. Well, hydrogen gas is an element in its natural state, 0. Copper 2 oxide is an ionic compound. Copper is a +2 ion, so it's a +2 oxidation number. Oxide's a -2 ion, so it's a -2 oxidation number. +2 minus 2 is 0. Copper solid, element in its natural state, 0. Water, hydrogen's a +1, oxygen's a -2. +2 minus 2 is 0, so it all checks out. So now if we look at this, hydrogen went from 0 to a +1, and copper went from a +2 down to 0. Hydrogen did not change. Oxygen did not change. So hydrogen had an increase in oxidation number. It is oxidized, which makes it the reducing agent. Copper had a decrease in oxidation number. It is reduced, and it is the oxidizing agent. So that's how you use oxidation numbers to identify what is oxidized and what is reduced. Now there's some for you to try on the next page. If you're watching the video, stop the video now, and the next video will have the review of those problems.